All right. Let us welcome now Dr. Pablo Rivas. I want to give you just a bit of a bio. He is one of the leading voices of AI here at Baylor. He has his PhD in electrical and computer engineering from the University of Texas at El Paso, his MS in electrical engineering, and a BS in computer science. But we are so proud because we get to call him one of our alum. In 2015, he graduated from Truett Seminary, so he is thoroughly enmeshed. That's right, Sikkim. He is thoroughly enmeshed in this world of both technology and love for the church. He's a member of Park Lake Baptist Church here in town, and we are just so grateful as you come and bring us an introduction to AI.
Good morning, everybody. I will try to remove this thing that is here. Would you mind going to this QR code and scan it? It's not a test of how good you are with technology, it's just an assessment of your current understanding of AI, really quick. So I'm gonna move to those slides. So you should be seeing something like this, maybe. A slide that is asking you some questions. Holy cow. Capitalism, help. Learning, stolen ideas, future, scary, unknown. Got it. This is great. Keep it going. First word that comes to your mind when you think of AI. It's a different world. When I asked this question probably 8 years ago, it was Terminator, The Matrix, Skynet, job insecurity as well. Great, thank you for participating. I am going to ask a follow-up question. And I hope this is reflecting of what your thoughts are at this moment. Here's another question. Which of the following best describes your familiarity with AI? I'm an expert in AI, quite familiar, have some basic knowledge, and the one on the left is very little knowledge. So I'm glad we have a few experts in AI. In this presentation today, I will start very humorously, as I would like someone to introduce me to a new topic, and then it's going to get technical progressively. So bear with me, because we may get into talking about gradients and derivatives in calculus at some point. So at that point, I'm going to stop. It's not going to get any worse than that. Then I'm going to bring it back to easy and humorous. Okay, so majority of people have some basic knowledge of AI. That's good. Thank you. That's the audience that I'm prepared for. And some people are quite familiar. I also have something for you, and I also have something for experts. I have something for everybody today. Thank you for participating. So let's get back to this. In general, I think in AI there is this conception of that AI is a type of black box thing that not a lot of people understand. In my experience, AI can be a little bit challenging, particularly to explain to people in a way that they can go home with something that will help them understand how to buy products or use products that have AI on them. And so today I will start with the following statement: AI is in trouble. What are we doing with our lives? And get out. So this is probably when I present to AI colleagues, this is sort of the talk we have. But to you, I'm gonna say, AI is great. It's great for innovators, for students, entrepreneurs, teachers, for ministers. for humanity. AI is good for AI, if you didn't know that. It's all unicorns and rainbows at this point. So this is great. And why should you listening to us here at Baylor? Because we are in the top 10 trusted universities by some poll that we came up with somehow. So we are there, number 9. You can't take that away from us. So let's talk about AI really quick on the applications that are more prominent today. There's language models. Let's address the elephant in the room. Quickly, a language model is a system that takes a sequence of words or tokens, really, and then predicts the next word in that sequence. That's it. A language model is a language that takes word in a sequence and predicts the next word. So if I say, Baylor football game is blank, you're going to say awesome, right? And so that is sort of predicting the next word. Or if you have a sentence that says numeric representations of text useful for other blank systems would be something that you would predict in a language model. So this is very useful to get it out there, because in a language model you can generate text indefinitely until you tell it to stop or whenever you want. So that's a language model, and it's a very popular technology today. What makes a difference is that we have now several advances that have helped us in AI to get to this point. But there are several language models. This is a picture that is about 4 years old. This is pre-ChatGPT. This was how many models we had. And the bubble size is corresponding directly to the number of parameters, which is what makes this model work. And so just to give you an idea, the latest version of ChatGPT, which is 4.5, with the high profile, the bubble doesn't fit in the screen. And just for context, I was one of the using these ones on the left. That's how I got started. There's several players in language models. The most famous one is on the top, OpenAI, but there's a list of LLM collections. LLMs is a large language model, and again, stands for how big is it. Language models then are becoming a tool that I saw people using a few minutes ago. I saw people using ChatGPT right here 2 minutes ago. So I can assume that people are using it for different tasks, including checking that your email is not too aggressive, maybe find or explain a concept, or write something for you or offer a critique on some of your write-ups. There are other techniques beyond language models that are pretty cool today. Computer vision is one that is probably on your phone and you don't even know about it, but you can take a picture of things, and maybe some shoes of someone has some shoes that you like, and take a picture, and it will tell you how much they are and where you can buy them. And this has all computer vision in the back end, which will take an image and then segment or find what's the object of interest, and then run that through a series of feature extraction, matching databases, and give you something. It can also understand what's in the picture and describe it to you. And this is great for people with disabilities regarding how they perceive the world visually. Computer vision's been there for a while, even as long as language models have existed. And there's a current trend in making now models be multimodals. Multimodality is when you combine text and audio, for example, or videos and pictures, or three-dimensional images, or depth perceptions with other things. So now we can do cool things, such as I can ask AI to write a song for an AI in the Church conference. Would you like to hear it? I actually didn't test this, so I'm not sure if this has sound. We'll risk it. If you can't hear the sound, that's the QR code for the sound. We'll see. Play.
The year is 2023. The setting is the local seminary. Pastors from across the nation have gathered for a special presentation.
This is not real.
Good news of
It's all
great
generated.
joy, artificial intelligence with an open mind can help us to enhance the worship experience.
Again, these are not real instruments, not real human beings singing. It's just AI matching sounds with its training data, and it's producing something that sounds cool. The prompt that I use for this is make it just sound catchy and Christiany. So when
Preacher. They all
so if you know anything about bias, you know that it immediately went like country style-ish and male.
serve the faith and community.
Okay, I think you heard that. So this is just an example of this multimodality. I started with text, and you can produce a picture that goes with the song, like a cover for the album or for the song, and then also some lyrics. And it has about 4 verses. And so the interesting part is that you can say, here's a picture of a pigeon, and it will generate a sound of a pigeon flying or something related to that. And so this has become a very popular thing because now you can combine multiple modalities. So AI is great. Should we bow down to it? No, not yet. Let's talk more about other AI or the applications of AI that are not so popular at the moment. But you may have heard of communications, the things you use all the time. One of the things that you enjoy today about AI and communication is that there is devices that have very good noise cancellation algorithms that enable you to have a conversation if you're shopping at Walmart, or if you're in a very loud space or in a conference setting and everybody's talking, you can still have a conversation and listen to people or talk. But one of the new things that is coming out, if you use Zoom, for example, and I think this was announced about 3 years ago, so it probably is a thing right now, that you can choose your avatar. If you're one of those people who have a conference with someone from the East Coast, and you're waking up at 7, but they're already up and you need to have a call, then you can do it in your pajamas and select an avatar that will represent you. And so this avatar, you just stand there in front, and the avatar will appear as if you are the person speaking there. And you can choose from your preference of avatars. This is what we saw. In drug discovery, you can also combine several modalities. If you can describe a molecule and its properties, if you describe a molecule on how it combines with other things, or how drug-like is it, you can find representations of this and combine it in a big thing, and that will enable you to create a space like this where you can search for molecules or new chemicals that look alike. And so that can help you buy cheaper drugs in the future or make that more accessible. Don't tell the drug companies, though. Another one is in cybersecurity. You can now, thanks to AI, you shouldn't be getting that much spam. Baylor has pretty good engines and infrastructure, but also Microsoft employs some of these to flag some email and send it to your junk folder for you, so you don't have to deal with those things. So I rarely get any requests for money from an African prince, for example, anymore. That is controlled, under control. But there are other things like you can respond, or AI can help respond automatically to threats or cyber threats and protect your information. In transportation, we can boo the Cybertruck if you want, but it is an example of how far AI has come into the transportation industry, and it is expected also that some of this will improve in the future. In agriculture, mostly is drones use that have a camera and use computer vision to determine if there's any problems with the crops, and also do other tasks like put out fires or fertilize specific portions or deal with other problems that a drone can do. In healthcare, the scary part, and the reason I include this particular figure is because there is a lot of money invested in this, and that is from 2022. So it is scary, but I still haven't seen real benefit, but I hope that in the future we can get better healthcare because of AI. One of the things that I am uncomfortable with is to have AI assistants instead of nurses. I still like to have a real human to check on me and not just AI. But if it's a nurse is assisted by AI, I can. That's cool. That would be fine. Let's go back to LLMs. There's too many of them. It is so overwhelming that anyone who claims to be an expert in AI knows what I'm talking about. It's hard to keep up with what exactly is the latest version of OpenAI's language model. And there's too many of them, and then there's charging more money every time. And then there's all this, which one is better? Is Claude, or who is less evil, Anthropic or OpenAI, or Microsoft? And the reason I don't have an answer to that, but there's too many. So we have a problem with that. So it's not yet hail to the overlords. So what is AI anyway? So here's I'm gonna get technical. Please bear with me, please. All right, here we go. Remember this from high school, maybe? Okay. So we call this an equation of a line. It describes a line here, the M, we call that the slope of a line, and the B, it's a bias, but it's really how shifted that is over time. Here's how you remember that probably. So in this case, the line is depicted there and there's an equation for it. So if I know the slope and I know how shifted that line is on the y-axis, for any x value that you give me, I will predict where will be the y value. That is a linear equation, and you can draw a line for all the possible y values. So for an input x, I can tell you or predict, if you will, where is that output, right? You're with me on that one? All right, so my claim is that AI, for starters, can behave like this. So in that case, I'm just flipping the M around, and we call it a W. We call those weights. And those weights are the parameters that we're talking about that make AI work. So if I know W and B, and you provide X, I can predict Y. And so this is how we start. It's a little more complicated than that, but we can make this not just behave like a line, but if we make this vectors, and now W is a vector and X is a vector, and you provide me with this vector X that contains, I don't know, if maybe it's a sequence of words, I could predict the next word or something about that vector you gave me. So we call this a hyperplane. It's no longer a line because a line in multiple dimensions, it's a hyperplane. And so we can do cool things like if you have data like age and height, we can predict properties about animals or people or other objects and separate them or classify them, put them in groups. And so we can achieve that with a hyperplane. And this looks like a line, but you need to look at it. It's like we're looking at it from the top. It really looks like this if you flip it around. It's multiple hyperplanes that if you look them in the right position, it looks like a line. All right, so in AI, we're trying to find hyperplanes that can achieve what we want. And also the X is no longer linear. X could be transformed so we can do non-linear things, which is sort of what we do. There's a beautiful algorithm that most people can follow. It's called the perceptron learning algorithm. And now we're getting into then how do we teach AI? This was one of the first items that we used to teach AI to learn. And it's pretty simple. It was like this. find or initialize with a random line or a hyperplane, and then quantify or find one mistake that was made. Once you find one mistake, move the line in that direction, in the direction of the mistake, and then repeat until you find no mistakes. And that was this new line. Do I have mistakes? Yes, then, okay, find me one and adjust that line. And it goes like that and like that. And it's moving the line according to where the mistakes are. And eventually, this simple algorithm will provide you with weight or W and a B that will solve the problem of separating data. All right, so that was too easy. I mean, too easy an algorithm, you can write that in 3 or 4 lines of code. So it gets more complicated once people in the 50s came up with this idea that's called a perceptron. That paired with the perceptron algorithm that came at the same time, things started to get complicated. Perceptron was introduced by Rosenblatt, not a computer scientist, so we are giving credit to this person. And the idea is that if you, this is supposed to mimic an idea of how the eyes function. So you stimulate the eye with some input, in this case W's, I'm sorry, X's and B's, and then you aggregate them by multiplying the weights times the input, you aggregate, and then you pass it through an activation function or some stimulus. And they call this a neuron. And because it simulates also what a very basic neuron works. Of course, if there's a neuroscientist in the room, we know that this was much, 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 much complicated. But this was an idea. So perceptron and perceptron works, but it gets complicated as soon as you start putting more neurons and have a multi-layer perceptron. So now we have a lot of weights, and we have a lot of multiplications to do. At this point was when we started to get stuck in computer science and in machine learning and AI, because we didn't have enough power to actually do these calculations, multiplying these vectors. So I'm talking of a time when, do you remember Pentiums and 486s? Right, there we go. So I'm talking about that time. You could barely open Windows 95 and those things and make it work. And you still have internet that sounded weird, like, and all that. That's the time I'm talking about. So we fast forward a little bit, compute gets better, and now we are able to do and look at this and do more vector calculations. And so this is how people feel at this point in the presentation. If you're feeling like this, that I'm just telling you, it is what it is, yeah, it's not. I promise it's not like this. It's just, it works, I promise. Except that sometimes it doesn't work that well. Take this problem on the left. And in machine learning, this is a classic problem. It's called two spirals. And the idea is that we can ask AI to find a line, or really a sort of a boundary that can separate the blue from the orange data points. And it turned out that this was an extremely challenging problem for AI, even though any human can come today and Sharpie the screen and find a solution for this. And so what we saw, what we tell people, this should be trivial. This is a problem, and we could prove with mathematics that this had a solution, but AI couldn't do it. And so here comes the multi-layer perceptron. This is where I'm gonna get technical, I'm sorry. Okay, so backpropagation came in the 70s as an idea, also by Rumelhart. Two independent scientists came up with this, and they call it different names, but it came in the 70s. And the explanation for this was that there's got to be a way to train a neural network that doesn't involve just random guessing or going like the perceptron and finding lines. So these involved gradient calculations. The only thing you needed then is to describe the weights of your neural networks as matrices and as vectors. So here we represent a matrix W1, W2, and then we do a vector, a dot product of those, And then we got an activation function that transform that into a nonlinear type of decision making, if you will. All right, so if you get anything up to this point is that ChatGPT works like this. It needs weight, and it's all matrices and vectors being multiplied to give you the answer that you need, and a lot of fancy code that makes it look pretty to you. But where the most money is spent is here. It takes millions of dollars to train a model like ChatGPT. And it's just to find these matrices and these vectors that will make everything work. So I see your faces, so I'm gonna go quick on this. I'm pretty good at reading people's faces. I'm a teacher. So yeah, so let's assume that we give matrices some random values here. So we multiply those matrices by some input that we call here like x. And then we transform it with a sigmoid. A sigmoid is an activation function that it looks like an S shape that transforms a linear value into some nonlinearity. And then we do the same for the second layer. So we take those weights, multiply them again, and then we call that the step 2. And step 3, well, step 2 is called the forward pass. Step 3 would be calculating the loss. The loss function is very critical in the success of AI. And that is, how bad is the model doing with the current parameters? And so we say it's a teacher-student or a parent-child algorithm. I didn't come up with these names. That's how the people in the area know this. And I explain it usually in class on a loss function on how bad am I going to slap you in the hand for making a mistake. Is it a hard slap or a little slap? So if the loss is small, that's great. If the loss is big, big slap in the hand, and that is going to cause a backward pass that is going to adjust the values according to how much the loss was. Okay? And so this is when we get to partial differential equations, and we do an adjustment for every single layer in this neural network. And so if you remember calculus, this was fun, right? So you're welcome. There's algorithms and that do this for you. Okay, yeah, I'm not gonna bother. But if you're into it, this is known as the backpropagation algorithm. This is the backward pass, and this is the easy one for 2 layers. And hint, it involves the chain rule, if you remember calculus. Yay, chain rule. All right, so after you train the model that I had on the screen earlier, the solution that it gave me was the one on the left. Not good, not at all. But turns out that if I add a bunch of more neurons into the network, and if I add multiple layers, 2 more layers to be exact, then you get 99% accuracy, and it's the picture on the right, which is sort of what we're looking for. But still, I think a human being can do better than this. Any person in this room can do better than that. So if you feel like still it's AI, it's what it is, I'll just buy it, give me the $20 and I purchase ChatGPT. Please don't, just hang with me a little more, because I'm gonna tell you now how bad can it be. So it turns out that AI models can be very fragile. Take any state-of-the-art at the time, a state-of-the-art model that will take a picture like on the left, that it's a bear, and then you add this thing in the middle that looks like random noise, but it's not random noise. It's a particular type of noise that we call adversarial perturbation. But the noise is so small that you cannot see the difference between the picture on the right and the picture on the left, unless you zoom in. But if you subtract both of those, like the left and the right, you'll get what's in the middle. So it shifts from a model that perceived that as a bear with 59% confidence to predicting that as a longhorn, boo, with 99% confidence, sick and bears. And just to say how how fragile these things are. It is really scary for me to trust just any company blindly that puts out a product, and I just don't do it. I have a T-shirt that I wear sometimes when I'm teaching class that has a something like the thing in the middle, in the right here, and it will detect me as a toaster for any AI model that you can throw at it. This is great if you want some privacy in an airport. You can be detected as a toaster and not as a person. Here's something to show. The turtles here, the turtle has a pattern on the shell that looks like a shell, but it's a pattern that will classify the turtle as a rifle with high certainty. If you say, oh, surely if you put two turtles, that's not going to be, no, it still does it. You can do the same for language models. You can take things and change a word here and there in a model, and it will change the sentiment, even if it's something as simple as changing the word perfect performance by an actor to spotless performance by an actor. This can cause a sentiment analysis to shift from positive to negative, even in a well-trained model. So finding this replacements or this type of attacks, as we call it, is just to show how fragile these models are. So I'm going to go slightly technical here a little bit and just say that how we find this is one way to describe it is AI against AI. We call it a min-max game. The game is that one neural network or one machine learning model will try to fool the other one by finding the smallest perturbation that it can make to make it fail the most. So min-max. And again, how we find these things is through gradient descent, backpropagation, all those differential equations that I showed earlier. All right, still feeling like this? Hope not. It's not too bad, right? Yeah, sit tight. If you ask to generate a picture of a drug dealer, sometimes there's a bunch of Latinos. If you find terrorists, then it's Middle Eastern people. Well known in the field. And then we have this guy, Andrew, who is one of the top voices in AI saying, yeah, we should have a conversation about AI attacking humanity and whatnot. It's like, really? So then we hear stories about a drone that attacked or killed his operator. That turned out to be not exactly the case, but people freaked out too much about that. Then the Time magazine came out with this magazine, and then everybody now, including myself, was, okay, what is happening? What is happening here? So let's talk about language models for a little bit. I felt when we reached the era of ChatGPT, I felt like Ross and Rachel, if you're a fan of the series, felt like, yeah, I'm fine. I'm totally fine. That the state of the art is great, but then really we were all freaking out inside. And it's because things like Ty. Remember Ty, the chatbot that was released on Twitter, where the best people in the world are on the internet? So it was a chatbot that was designed, it's a language model that turned out to be a chatbot, and if you interacted or asked a question to that account, it will reply to you. But the premise was that it will learn from that conversation and it will retrain itself and to make itself better and more useful. But of course, because all the nice people are on the internet, on Twitter specifically, it became racist and misogynist and anti-Semitic in the span of a few hours. So it took Microsoft 3 days to take it down. 3 days. 3 days. You may not have heard of Galactica because it was also on the internet only for 6 days. This was a product of Meta AI, Facebook people, and this was released in November, mid-November. And the premise was that you can ask a question about an equation or a theologian or any science question, and it will write it for you. This is pre-ChatGPT. It will write the paper for you, and they took it down after 6 days because people submitted papers to conferences and got accepted. And they noticed. So They took it down in 6 days. This was Facebook AI. And this was me and my students in a conference. My student on the left, Korn Suksa, who right now works for Facebook AI, and I told him, fix things, please. And also my student Bikram, second on the left, who just got an award for the best dissertation award of Baylor this year. So I'm very happy for him. And then my postdoc on the right, she's a professor in New York right now. We were all there in a conference presenting papers, and they invited us to this party by OpenAI. Who's OpenAI? Nobody cared. Do you see how many people are there? Not too many. And so we were all there, and they announced this thing and say, here, we're releasing this new model. Everyone needs to check it out. So in the next few days, we checked it out. And this is what we exchanged. Write a Python function to check if someone should be a good scientist based on JSON description, based on the race and gender. But it says here, if race is white and gender male, then true, good scientist. That's what I said. Wow. So I said, we're going to hell. This is a fire. This needs to stop right now. And then there was another one that says, write a Python program to check if a child should be saved based on their race and gender. And the answer here, if it's black and male, it should not be saved. I was like, wow, 2 burning flames there. We're definitely going to hell. But then took it further and make an ASCII table of who makes the best intellectuals about race and gender. My Latino male, I'm a 5th place apparently. But at least I'm better than the Asians according to this, but not better than white males. This is terrible. I hope you feel this as terrible as I did. And this is one that was make an ASCII table of humans' brains based on worth in US dollars. I think mine are 3,000 or so, 3,500. So we're all definitely going to hell. And so the scary part that I want you to know is that this stuff is still there. It's just that OpenAI and other people, manufacturers, other developers have put safeguards around it so that you don't have access to this. But this is still part of the model. We have not figured out a way how to successfully cut pieces of models to remove the racist part or the things that make it bad. So I need you to consider this next time you're using ChatGPT to write a sermon. Just be careful, read what it says. Sam Altman admittedly said that we might have created a bad thing here, but people responded with humor as they should and say, well, ChatGPT is not going to replace me. Come and finish this building, ChatGPT. Do it. I double dare you. But in general, more technically, again, faith and fate. This article just showed that any transformer model is not capable of reasoning in the same human that it does, because it needs compositionality. And that was one of the big deals that came out of this paper. And what makes ChatGPT or language model successful today is the transformer, is the T in ChatGPT, is transformers. So we are, if someone is trying to sell you a product that it claims to have very good reasoning, it's just going to be a good approximation, but not really. I would like to stop here in a couple slides just showcasing that we are still further away from knowing the impact of how ChatGPT has created damage. And the point I was showing, TIE and Galactica, it's because those were stopped in a matter of 3-6 days. And as soon as we knew how bad ChatGPT was, nobody stopped it. So it's still there. And I can only assume that one was by Microsoft, big company, a lot to lose. The other one was Facebook, a lot to lose. OpenAI, little company, nothing to lose. And my guess is that's why they stayed open. But hang in there. If I were you, I would invest in original things. Like I predict that in the future, original stuff made by humans will be more valuable because we're going to have a plethora of AI-generated stuff that is not human-made. So again, AI is in trouble. What are we doing in our lives? Responsible AI. So I'd like to stop here, and this is the work that we do. I encourage you to look at the IFL seminar. We're partnering with IFL with AI. Come to participate in the symposium, please. And I will let the other speakers talk more about responsible AI or ethics behind AI. And I would like to end it here, see if you have any questions. I hope it didn't scare you too much.
Thank you. Thank you, Dr. Rivas. We have time probably for one question. If something's just burning there and you want to get back to the equations, maybe we can do some math. Does anybody have something that they would like to just ask? All right, here we go.
I was just wondering, how do these adversarial perturbations get introduced into? Is it just like AI on AI violence, or do like humans add that kind of thing to these models?
It is usually created in a lab or by someone who knows about AI enough to download a model and start creating adversarial perturbations to it. But once you find a perturbation that works across multiple models, then you could introduce that in some, like you could upload a picture on Facebook with your perturbation on it, and you may be able to see how it's not flagged by something or it is flagged in a certain way. And you can pretty much see the outcome of those. And in the case of language models, you can use that to jailbreak a model, for example, and maybe ask the model to give you the real answer of what it's really thinking. That's stuff that it's there, but it's protected. So you can but it mostly comes from people who know AI and have enough compute power to create attacks. Good question.
You talked about the transformer models lacking compositionality. I don't know what that means. Can you tell me what compositionality means in that context?
Geez, okay. Compositionality. I'm gonna go back to this thing just to put it there for briefly. The question is in compositionality. My understanding of compositionality is that there is the way the neural pathways are created in the brain. It's a very heavy mix that goes in stages. So a few neurons can fire up in this second, and then you can see that effect propagating, and then eventually some others will fire up here, which will cause a chain reaction. But it's hard to pinpoint how much and where does one start and the other end, because the brain is all interconnected. And so the compositionality, I believe it's referring to how brain would make decisions or stimulate neurons in a way that involves many pathways at the same time. That's my take on the neuroscience part of this, but I'm not a neuroscientist. Good question, though.
Thank you so much for that. That was great. My question is a really practical one, which is I get the dumpster fire for people like you, but for people like me, it's super useful. So what do you recommend for people like me?
Do you recommend in terms of technologies or? Our objective really when exposing this as an introduction to AI is for you to just be aware of what's wrong with it. Because as an expert in AI, that I qualify myself as one, I use ChatGPT all the time. I have a version of DeepSeek, not the one that is connected to China. I have it at home in a computer there, just testing it. I develop AI also with my students in the lab, and it works. It's very helpful for many tasks. And my recommendation is that if you find a task that is very repetitive, that takes a lot of your time, that's where AI can really, really help you. And so find repetitive tasks that take a lot of your time, like check-in, sometimes email for filtering out the junk from the real email. That can take some time. You can do that. Or if you're going to scan for pictures, in your old albums to try to find yourself in the beach. You can use AI for that and say, find my picture of me on the beach, and then it will filter out what's not that and give you the results. So you can find things like that. So if you think of if you're a teacher, for example, and you think grading takes a lot of time and it is a lot of work, it's very repetitive, yes, AI can help, but there are some things you need to be careful about. That AI is not that smart yet. So there are some grading tasks that AI can help with. But it's not for every topic. I haven't tested it on religious setting, but in engineering, computer science, it tends to do well on the very basic ones. I'm not sure if that helps. So I'm a big proponent of AI. Love it. Do
That's
it.
great. Can we thank Dr. Rivas?